Yes, very good day and welcome all of you to another session of virtual classes of science here. And in the last sessions, we have started with the crash problems of one-dimensional motion. And in this, we are especially going to deal with a relative velocity concept in one dimension. Okay, so what is relative velocity? Everything in physics is relative, right? You all know that there is nothing which is absolute. What I mean by relative and absolute. So you cannot say any body is at rest or any body is in motion because everything is relative to something else. For example, suppose there is a car which is moving on a road, or a rocket which is propelled, or a boat which is crossing the road, or if a person is walking through a road, anything, you will say that with respect to the earth, the particle is in motion. So in that, what we have considered, the earth as origin, or earth as a stationary or a rest condition. Look at earth. With respect to the sun, the earth is revolving. That means earth is in motion. So earth is also not at rest. This is in motion with respect to sun. What about sun? Is it at rest? No. The sun is also revolving, or we can say the entire solar system is revolving around the center of the Milky Way galaxy. What about that one? Galactic center. That is revolving with respect to what? The center of the universe. And we don't know what is exact that, okay? Because there are n number of universes according to a concept. So you cannot say anything at absolute rest. So we have only one concept, which is relative rest. What about motion? What about relative velocity? Velocity itself is relative. It is nothing new. There is no new concept in this one. It is all the same what you have learned. We will see the velocity definition. What is velocity? Let us picturize that one. Suppose there is a body moving along the x-axis with a velocity of, say, A is moving with the velocity of VA. How does you say that? I am saying that a body A has got a velocity, so VA. What is that actual definition is? This is the velocity of A with respect to or relative to the origin. Relative to the origin, because we have velocity of origin is equal to 0. So in all the problems, whenever you say velocity, that is always a relative concept. You are relating that one with respect to a origin which is at rest. So I can write velocity of A with respect to O, because O is at rest. This is equal to VA minus VO. This is VAO. Instead of writing in that manner, we are just simply writing the velocity of A is equal to VA. If you have got this idea, it is easy for you to understand the concept of relative velocity. Now, instead of O, suppose there is a particle at this point which is B, that is also moving with VB, and this is A, as I shown earlier, with VA. Now VB is not 0. Here VB is not equal to 0. Writing velocity of A relative to what? A moving particle, which is relative to particle B. We write VAB. What is that? It is VA minus of VB. This is an easy manner. Those who are preparing for preparing crash, this is the easier method for you to understand the concept. So what is velocity of A with respect to B? That is VA minus VB. Velocity of A with respect to origin is VA minus VO. The simple concept is clear to you? Okay. These are vector quantities, so I can write it in this manner. What about velocity of B with respect to A? That also will be equal to VB minus VA. This is easy for you to grasp. So here we have the expression for the relative velocity of A with respect to B as VA minus VB and VB with respect to A as VB minus VA. and we know that vector velocity is a vector quantity. To take the difference of two vectors, what we need to do is we have say a minus b, two vectors. In vector resolution and vector resultants, we have studied that this is equal to a square plus b square minus 2ab cos theta. For theta is the angle between a and b. Now we can have two cases over here. First case, case 1, when the particles are moving in the same direction. When they are moving in the same direction. That means A and B are moving in the same direction. Just like the examples of one car is moving forward and another car is trying to overtake. And maybe like two trains are moving on the same track and one person is trying to reduce that, avoid collision. Just like that. Okay, we can have that kind of problems. In all that, we are having theta is equal to 0 because A and B are in the same direction. A and B are in the same direction. So theta is equal to 0 indicates what? Cos theta is 1. Substituting into that, our VAB will become root of VA square plus VB square minus 2VA VB. Cos theta is 1. This is A square plus B square minus 2AB. That is nothing but A minus B. So in 1D, our expression for relative velocity when the two particles are moving in the same direction, always remember same direction, is A minus B or VA minus VB. What is the second case? Second case is case 2. They are in the opposite direction. That means two trains coming on the same track in the opposite direction. Or a train is moving and a fly is moving in the opposite direction. That can be a bird is moving in the opposite direction. That can be the possibility. That means opposite direction and in parallel, whatever you want to call. Theta is 180 degree. What is cos theta? That is minus 1, as you know. What will be the expression? VAB will be equal to root of VA square plus VB square minus 2VAVB into minus 1. What is this? This is positive, right? Expression is simple, a plus b whole square. This is VA plus VB. We can conclude, we can avoid all the directions from here. Opposite direction, take the sum of the magnitudes. Opposite direction, take the sum of the magnitudes. Same direction, take the difference of the magnitudes. That will give you the value for relative velocity. Now, we are going to start the problems, and in all the problems I will be using a highlight term for solving relative velocity. I call that one as arresting. Arrest. Whenever there is a relative velocity problem, I will arrest one body, or I will treat that body is at rest. That is what we are going to do. So let's start with the problem. Here is the first question to you to do the concept of arresting in the case of relative velocity. Arrest one body. So you have two trains, each 50 meter long, are traveling in opposite direction. That means opposite direction 180 degree. You must be remembering the formula which I have given with 10 meter per second and 50 meter per second. Question is time taken for crossing. Problem is very simple, but I will teach you the way of arresting. What is meant by arresting? We have two trains, say A with 50 meter long, moving with VA equal to 10 meter per second, and B 50 meter long, moving with VB 50 meter per second. Is it 50 or 15 meter per second? Is it 50 or that is not 50 meter per second, I'm sorry. This is 15 meter per second. Okay, 1 5. So 15 meter per second. So we have that situation in which we have to do the problem. Both are moving. What I mean by arresting is use the technique of arresting. That means arrest one of the body. Arrest means bring that body to rest. What I am doing is, I am making this body B to be at rest, or I am assuming that train B is stationary at a particular station, or that is situated at a station with a length of 50 meters. Another train on the other track with the same length 50 meters. So that we will take the velocity as what? Velocity of A with respect to B. We brought B into rest. So that is the idea. I am bringing one body to rest. So B is at rest. Another one is coming with the velocity, which is the velocity with respect to the other body. This have to cross that. So what is the total distance that to be covered? In order to cover the total distance which is to be travelled is 100 meter. What is the velocity? This is equal to what? Relative velocity of A with respect to B. We know what is relative velocity of A with respect to B. They are in the opposite direction. So we will get VA plus VB, that is 25 meters per second. We got the velocity and we got the displacement or the distance to be travelled. What is the time taken? That is simple for you. 100 by 25. 4 seconds is the answer. Problem is very simple. Why I have given this problem is, try to understand the concept. Try to look into the problem in a different manner or from a different angle. Arrest one body, look at the other body. Just bring that one into a single particle motion problem. Chasing problem or an overtaking problem. Question is, a bus is moving with 10 meters per second on a straight road. A scooterist wishes to overtake the bus in 100 seconds. If the bus is at a distance of 1 kilometer from the scooterist, with what minimum speed should the scooterist chase the bus? Question is like this. Situation is, bus is moving with, say, VB equal to, we have 10 meters per second, and the scooterist is at a distance of, say, 1 kilometer, that is 100 meter. He wishes to overtake. We want to find Vs. The time is 100 seconds. So what problem is obviously to find what relative velocity of scooterist with respect to the bus. That is what we need to find. Okay. So if I take VSB, that means scooterist velocity with respect to B, VSB, they are in the same direction. So VSB will be equal to what? Vs minus Vb. Velocity of scooterist with respect to B will be equal to Vs minus Vb. If that is the velocity with the scooterist is moving, how much distance he want to cover? He want to cover 1000 meter in a time of t is equal to the scooterist, t is equal to 100 seconds. In that platform, what about the situation of the bus? Bus is at rest. So I have arrested the bus by taking the concept of relative velocity. Can you see that? So what we did? We took the bus is at rest. Now the scooterist is moving with the relative velocity of Vs minus Vp, and he wants to overtake the bus in 100 seconds, where the bus is at a distance of 100 meters, 1000 meters, 1 kilometer. We can obviously find the velocity of scooterist with respect to the bus as distance divided by time is by t, which is equal to 1000 divided by 100, which gives me 10 seconds. So don't go for the answer 10 meters per second right now, because this is not the velocity of the scooterist, because this is the velocity of scooterist with respect to the bus. We found this one as Vs minus Vb. So Vsb is equal to Vs minus Vb, which is equal to 10. So what is Vs? That is 10 plus Vb. And Vb is given as 10 for you in the question. So this is 10 plus 10, 20 meter per second. So have the patience of completing the problem whenever you are doing any entrance problem, because there will be always chances of fouling. Okay, question will foul you and you may end up with the wrong answer. So wait for that and be patient to get the right answer. Problem of a disaster or to avoid a disaster. Problem of chances of an accident of two trains. What is given over here is two trains on same track are approaching each other with equal speeds of 40 meters per second. The drivers begins to decelerate because they want to avoid the collision simultaneously when at 2 kilometers apart. Assuming uniform decelerations, the value of deceleration to barely avoid collision should be. That means within that 2 kilometers, this have to come to stop. You can do this one in a different way, but I am using my method which I am talking about, which is nothing but the arresting method of one body. We have two trains, say A and B. One is moving with 40 meters per second and B is also moving with 40 meters per second. And when they are at a distance of say 2 kilometers, that means distance is 2000 meters, the drivers observe that there is a chance of collision and they start decelerating. That means this person is exerting an acceleration in the backward direction. We can call it as A, and this person is also AB. And it is also given that AA is equal to AB. We can take it as say A, because in the problem itself it is given that they are moving with uniform decelerations. And this is given as VA is equal to 40 and VB is equal to 40. Opposite directions, we know that relative velocity of say VA with respect to B, I can write it as what? VA plus VB, that will be equal to 80 meters per second. Now I will tell you can apply the concept of arresting. I am taking A is moving with a velocity of 80 meters per second. At that time, what I can assume, B is at rest at a distance of 2000 meters. So VB is equal to 0. I have arrested B. Now what it should be? A have to stop before it collides with B. That means at least maximum, barely to avoid that one, it can come maximum to 2 kilometers or just before that. So what this person have to do? This person is exerting an acceleration or deceleration. So A of A with respect to B. Concept of relative acceleration. Concept of relative acceleration, we know that is also equal to AA minus AB. Acceleration of A minus AB. They are in the opposite directions. I can take this one as AA plus AB. Or I take this one as A, I can put it as 2A. So the deceleration of this one is equal to 2A. Our problem is solved, I can tell you, because this has got an initial velocity of this much. You are applying a deceleration 2A, there is a displacement this one, and final velocity have to be 0. Final relative velocity of this one should be equal to 0. Correct? We got USVB A. Which equation we can use? We can use the equation which is V square is equal to U square plus 2AS. V square is 0. U square is 80 the square. It's a deceleration. So 2A is negative. So minus 2 into 2A into S. Okay, S is 2000. So I can write 4A is equal to 8, the whole square is 64, 6400 divided by 2000. 6400 divided by 2000. Solve it, you will get 64 divided by 20, or 64 divided by that one is 3.2. Now find A. Acceleration, that is equal to 3.2 divided by 4, which is equal to 0.8 meter per second square. Option is D. So I will repeat, you have to select 2A, otherwise what will happen is you will end up with an answer of 1.6. That is wrong. Okay, so you have to be careful while doing the problems of relative velocity. We are again with the problem of a collision, just like we did for the trains. Here there are two cars. Problem is, two cars A and B are traveling in the same direction. Same direction. That means the relative velocity will be difference of 2. Same direction with V1 and V2. And given that V1 is greater than V2, that means velocity of car A is greater than velocity of car B. When the car A is at a distance of D behind B, the driver of A applies brakes, producing uniform retardation A. There will be no collision when there are 4 options. You are trying to avoid the collision. Okay. D less than V1 minus V2 to the whole square divided by 2A. B, D less than V1 square minus V2 square divided by 2A. Option C, D greater than V1 minus V2 to the whole square divided by 2A. Option D, D greater than V1 square minus V2 square divided by 2A. Problem is to find no collision possibility. We have two cars, same as I used to say, A and B. One moving with V1, the other one moving with V2. When they are at a distance of D, driver of car A applies a retardation A. And this is not retarded. Okay. So I can say relative velocity of A with respect to B is equal to what? That is V1 minus V2. Relative acceleration of A with respect to B is what? This is having A and velocity acceleration of B is 0, that is equal to simply equal to A only. A minus 0 will be A. And the distance to be covered is what? D. For no collision, what should be the final condition? VAB should be equal to 0. That means final velocity of A with respect to B should be equal to 0. So this is the initial velocity, correct? We can put it as UAB. I have formulated the problem to the arresting condition. If you want, you can just imagine it like this. B car is at rest at a distance of say T from car A. The car A was initially moving with UAB and the driver applies retardation A. He wants to stop the car in this distance, that means VAB should be equal to 0. We got all the inputs for velocity displacement relation. Okay, V, U, A and D, S is equal to D. Substitute, what is that? V square is equal to U square plus 2AS. V square is 0, U square is what? V1 minus V2 the whole square. V1 minus V2 the whole square. A is negative because it is acting in the negative direction. Minus 2A D. Rearranging, I'll get D is equal to say V1 minus V2 the whole square divided by 2A. For no collision to happen, this is the condition for collision because D is covered and it will hit B. Okay. So what should be the minimum criteria? It should be greater than V1 minus V2 the whole square divided by 2A. So which is the option? We have the option C as the right one. So with that, we have seen the elementary questions or subject oriented, or we can say the concept oriented questions of relative velocity. With this, you must have understood how to find relative velocity, relative acceleration, how to solve the basic problems. So with that, I'm winding up the session 1 of relative velocity. We will move to the second session and in which we will see many advanced questions. Thank you all, and you have to go through this session and also you have to follow the next session and the next video. Thank you very much. So not only that, see, like if you are having any doubts in these type of problems or maybe in any kind of problems which are related to your specific studies, you can put that one as like a comment and you can ask such doubts so that we can clarify, so that I can clarify the problems also. Okay, so just go through the session and try to understand it and put your comments. Thank you.